Moving on into 2-8, we're going to talk about two variable inequalities. Now, you need to remember what an inequality is. An inequality is when we have symbols such as greater than, or symbols like less than, or greater than or equal to, or less than or equal to. Okay? So let's go ahead and talk about some of our vocab. A linear inequality is an inequality with two variables whose graph is what we call a region. R-E-G-I-O-N, a region of the coordinate plane that is bounded by a line. Okay, now maybe you're a picture person. If we have an XY chart, in other words, it would be a line, and either above or below the line would be shaded. Okay, so that's what I mean. That's in two variables, x and y. The boundary is the line. That's the boundary to the region. The half plane, it is, well, the half of the coordinate plane. Okay? If you are wondering about this picture, you see the shaded area here? The shaded area represents the half plane. The line is the boundary. Now, a test point is what you can use to determine which half plane to shade. If you'd like to use test points, we encourage you to use the easiest one. We encourage you to use 0, 0. The only time you wouldn't use 0, 0 is if the 0, 0 was part of the line. Let's look at problem 1. What is the graph of each inequality? You did study this back in Algebra 1. This should not be too difficult for you. You just have to recall some things you've learned, and it was in Chapter 6 when you learned them. First thing, you graph it just like you would a regular line. So your y-intercept, your b value is -1. Your slope is 3 over 1. So we start by going down 1 and making a dot. And then we go up 3 over 1, up 3 over 1. Now be very careful when you connect. You should remember that it is, if this see this inequality, how it's greater than, it is not equal to. Therefore, we use what we call a broken line. That is because it cannot be equal to a broken line, and this is not an equal to problem. So when I connect, and when you connect, you need to use a broken line. Using a broken line tells you that it approaches the line, but it cannot equal the line. Now, because it is greater than, that means you shade above. So pretend your line is falling. See it? Pretend your line is falling. Shade above your line. And that is the half plane. Now, some people do not like the above or below approach like I did here. They use a test point. And this is actually more mathematically probably true. Alright. Either one's fine. I prefer just looking above and below. But if you did a test point, so can I write option here? If you did a test point of 0, 0, 0, 0 is right there, okay? It would be on this side. Well, we would plug it in. Okay? So I would do, is 0 greater than 3 times 0 minus 1? I replaced x and y with 0. You would say, yes, 0 is greater than -1. Because this is true, you would shade the half plane with the 0, 0. So, if I can indicate maybe with a highlighter, see how well you can see this. Here's 0, 0. Since I know that's real hard to see. I put 0, 0 with a highlighter. Since that's 0, 0, you would shade this half plane because this is the side that 0, 0 occurs on. Moving on. So you can always use that test point if you want to. The only thing you don't want to test, and maybe you want to take a moment and pause this, the only thing you do not want to test are points on the line. Moving on to part B. The y-intercept is -1. The slope is 3/1. So again, I will start by going down 1 and drawing my y-intercept. Then, like I did before, I'm going to go up 3/1. This time when I connect, I am going to use a solid line. And the reason I use a solid line is because it is equal to. See that line under the less than or equal to? Because it is equal to, I use a solid line when I connect. But now I have to decide where to shade. In order to decide where I shade, I see that this is a less than sign. That tells me to shade below. So I look at my line, and I pretend my line is falling. Anything over here, it would touch. This is the half plane that you shade approaching your boundary line. I'll show you the test point one more time. That is an option to test a point. Let's say that you decide again to test 0, 0. Well, this time you would say, is 0 less than or equal to 3 times 0 minus 1? Well, that's like asking, is 0 less than or equal to -1? The answer to this is no, so you would not see where 0, 0 is? You would not shade on this side, you would shade on the other side. Moving on. What is the graph of y is greater than or equal to -2x plus 1? Now something we can realize right off the bat is B is our answer because it does need to be a solid line. It needs to be a solid line because it is equal to. But we should probably discuss some more stuff. You should also indicate that the slope is -2/1, and you should also indicate that the y-intercept is 1. One more item is that you should also indicate that this would be shaded above. So if we look at all of our criteria, B fits that. Your y-intercept is at 1, your slope goes down 2/1, down 2/1, down 2/1. It is a solid line because it is equal to, and it's kind of hard to see because it's black and white, but this side, which is above the line, if the line was falling, it would be above, is correctly shaded. Problem 2. Entertainment. The map shows the number of tickets needed for a small or large rides at the fair. You do not want to spend more than $15 on tickets. How many small or large rides can you ride? Let's look at the information provided. We have the information that a large ride is 5 tickets, and we have the information that a small ride is 3 tickets. The last thing we have is information that tickets are 25 cents each. Let's go over some more details. If we read again, we will see that you want to limit yourself, and you want to limit yourself to $15. Well, I'm hoping that you might be able to say $15 is the same as how many tickets, and that will allow us to determine our ticket limit. So how many would $15 give you? Well, if we divide it out, if each ticket is 25 cents, we do 15 divided by 25 cents, and we realize that we can buy 60 tickets. And that's going to be our max. We don't want to buy any more than 60 tickets. Now what we need to do is come up with an equation using 2 variables. Why don't we let L represent the large, the large rides? And why don't we let S represent the small rides? Well, if we have a limit of 60, that means that what we get has to be smaller than or equal to 60, because we are limiting ourselves to 60 tickets and under. Think of this in terms of large and small. Now, L and S stand for how many large rides and how many small rides, but 60 is in terms of tickets. So we need to put 5L, which stands for 5 tickets for every large, plus 3S, which stands for 3 tickets for every small, is less than or equal to 60. The last thing we need to do is solve. I'm going to solve for L. Okay, so I'm going to solve for L so we can graph. So I get 5L is less than or equal to negative 3S plus 60. Divide by L, and I get L is less than or equal to negative 3 over 5S plus 60 divided by 5 is 12. So here is my y equals mx plus b equation. You can graph that, or you may also graph using intercepts. This looks like it may be fairly difficult to graph. So what I'm going to do is I am going to choose not to graph using y equals mx plus b. You may if you want. I am going to graph using intercepts. Okay, and so that, guys, this is why we did everything in Chapter 2 so far, so you can decide which way is easiest for you to graph. I have noticed that it is going to be much easier to graph using intercepts in this case. So I'm going to do 5L plus 3 times 0 is less than or equal to 60. That's going to give me 5L is less than or equal to 60. And that's going to give me that L is less than or equal to 12. So I'm going to count up by 3's here, and I'm going to go to 12 and make a dot. 1, 2, 3, 6, 9, 12. There's my dot for 12. I skipped by 3's. And now I'm going to solve for S. So 5 times 0 plus 3 times S is less than or equal to 60. That's really 3S is less than or equal to 60, or S is less than or equal to 20. I'm going to choose to skip by 5's to graph this. 5, 10, 15, 20. And now I have a nice, easy graph that I can shade with. If I connect my lines, I may use a solid line because it is equal to, and I did notice that it is less than this line because I can't spend more than 60 tickets. So everything in this shaded area, I'm not going to go into the negatives because you can't ride a negative ride. Everything in this shaded area is an answer. Okay, let's point that out. Everything in this shaded area fits my limits. Okay? Now if you're kind of like, what do you mean by that? For example, if you buy 5 small and 3 large, that is going to cost you less than $15. And why is that an answer? Because it's right here in the shaded region. 5 small and 3 large. So anything inside of that shaded area fits your limits. You could have graphed using y equals mx plus b, or you could have graphed how I did using intercepts.